This is the video for final exam review day 2. It's all about chapter 5 today, which was how to graph things and how to describe data with numbers. So first thing we will review is median. The median of a data set is where 50% of the data is greater and 50% is smaller. So it's like an average, except for it's a little bit better when there's outliers in your data, which we've talked about. To find a median, you look at how many numbers there are in a list and you cut it in half. And that number is either a decimal or it is not, which we'll look at in just a second. One thing you might want to do first is put your numbers in order. So here's the same list of numbers, but in order from smallest to greatest. In this list, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. So if you do 9 divided by 2, that's a decimal, 4.5. But that means we're looking for, rounding up, the fifth number of the data to be the median. So 1, 2, 3, 4, 5, this number 4 here would be the median. Okay, and I'll even mark that here. So here's our median of our data. Notice that there's 4 numbers below it, there's 4 numbers above it. This list, let's put it in order. We're going to find the median. In this list, there's 1, 2, 3, 4, 5, 6, 7, 8, which is an even number. If you divide 8 by 2, you get 4. But here's the deal. If I pick the fourth number, that would be 3. So let me pretend that I think the answer is this number right here. This is going to be the wrong answer in just a second. So if this were the case, what would happen is we would have only 3 numbers to the left of it and 4 numbers above it. Again, this is supposed to be where 50% of the data is greater and 50% is smaller. So actually, we do something a little bit different with even numbers. If there's an even amount of data, 8 divided by 2 is 4. That means in between the 4th and the 5th number is where the median would be. So sometimes the median isn't an actual number in the data set. See now how I've cut it in half. There's 4 numbers below the bar and there's 4 numbers above. So how do we get the answer? We just take the numbers to the left and right, 3 and 4. If you add those up, you get 7. We're going to take the average of those two numbers, 7 divided by 2, which is 3.5. The next piece we learned with this was being able to get a 5-number summary. So a 5-number summary is the minimum, the first quartile, the median, which we've just found, the third quartile, and the max. All right, so let's fill in what we know so far for the one on the left. All right, we know that 4 is the median. The min and the max are pretty easy to get next. The minimum is just the smallest number. The max is the biggest number, so 1 and 9. The quartiles then are the medians of the lower half of the data and the upper half of the data, respectively. So this half of the data, there's 4 numbers, 1, 2, 2, and 3. If there's 4 numbers, the median will be between the second and the third number. So that's going to be where our median is of the lower half. So halfway between 2 and 2 is 2. So 2 would be the quartile 1. Halfway between 8 and 9, again, we're splitting the data in half. 2 numbers here, 2 numbers here. Halfway between 8 and 9 would be 8.5. So the 5-number summary for this data is 1, 2, 4, 8.5, and 9. Okay, let's do it again over here. We know that the, oops, I gave away an answer. That's all right. We know that the median is 3.5. The min is 2. The max is 15. Okay, I'll show you how the 6.5 came up in just a second. So again, there are 4 numbers below our median. So between the second and the third piece of data is where we will find our Q1. Between the 5 and the 8 here will be where we will find Q3. So halfway between 2 and 3 is 2.5. The reason this is 6.5, if you take 5 plus 8, you get 13, and 13 divided by 2 is 6.5. So the process is pretty similar for these two problems. The difference is if there's an odd amount of data or an even amount of data. Okay. Outliers. There's a formula for that, and here it is. So the formula, the first thing we want to figure out is this part, 1.5 times the IQR. IQR stands for interquartile range, and that you get by doing Q3 minus Q1. So if you do 8.5 minus 2, you end up with 6.5. What we're going to do with that is we're going to multiply it by 1.5. So if you multiply that by 1.5, you get 9.75. So this number is equal to 1.5 times the IQR. So to find out if there's outliers, we take quartile 1 and we subtract 9.75. So 2 minus 9.75 is a negative number. We don't have any negative numbers in our list. So what we would look for is there anything smaller than that in our data? If there was, it would be an outlier. Let's look at this one. We're going to take Q3, which was 8.5. We're going to add that 9.75 to it and get 18.25. Our biggest number was 9, which is smaller than this number here. We call this the upper limit, and this the lower limit. Since there's no numbers bigger than this or smaller than this, there are no outliers in this left-hand data. Let's repeat the process. The IQR of this set of data is 6.5 minus 2.5, which is 4. We're going to multiply that. Sorry if that looks like a subtraction. We're multiplying that by 1.5, and we get 6. So we need to take this number minus 6, and we get negative 3.5. We don't have any negative numbers here, so we don't have anything smaller, so there's no outliers on the low end. We're going to take 6.5 and add 6, and we get 12.5. But notice 12.5 is our limit then on the high side. 15 is bigger than that, which means 15 is an outlier. And if there was anything else in here that was bigger than 12.5, it would also be an outlier. So 15 is the only number bigger than that, so we have 15 as our outlier. Okay. So those are called 5-number summaries, so make sure you know how to do those. Both of Peshman's sections of AP Stats had an average of 92. So both tests had a mean of 92. His third hour had a standard deviation of 5, while his fourth hour had a standard deviation of 2. What difference does this make? So it would make a little bit of a difference in the picture. Standard deviation is a measure of how spread out the data is. So if something has a higher standard deviation, the data is more spread apart. So third hour would have more scores that are really high and really low, more spread out. Fourth hour with a small standard deviation, all of the scores would be kind of bunched together. So the scores in second hour are a lot more, this should say third hour. The scores in third hour are a lot more spread out than the scores fourth hour. Okay, standard deviation is a measure of the spread. All right, and then the last one for this piece, considering mean, median, standard deviation, IQR, place them in the appropriate category. So here's two lists. They're the same for these 5 numbers. The max is what's different. So the max here is 8, pretty close to the rest of the data. Here's where the median would be. Here's where the min and the max, Q1 and Q3 would be. Q1 and Q3 would be the same here and same as the median. So having an outlier, 20 is an outlier. Having an outlier doesn't mess up the Q1s or the medians. See how these are exactly the same as these ones. So what's not affected is the median and the IQR. 7 minus 4 is 3. 7 minus 4 is 3. What would change is our data just got a lot more spread out. That would be standard deviation. And if you took the average of these, it's going to go up. So this is our median. Our average is probably going to be somewhere over here. So the things that are affected are averages and standard deviations. If you know you have outliers in your data, the best numbers to use for describing the data is median and IQR. Okay, let's move on. So then we got into visually representing graphs. The first one here is a pie chart, as you can see. So one thing about pie charts is they need to add up to 100%. All right. If 500 people were surveyed, how many people would prefer action films? So if there's 500 people in this pie chart, they gave us percentages, okay? And they gave us numbers here, but we're going to ignore these 6, 5, 4, 4, 1, and we're going to assume, what if this is the same data was true about 500 people? Okay, so if there's 500 people surveyed, we would want to multiply that by the percentage that like action, which is 25. So 500 times 25%, 125 people. Next type of graph is a bar graph. So bar graphs are for categorical data, which we will talk about in a second. They have gaps between the bars, unlike a histogram, which we will see soon. So there's a category, and we look at how many people, what are the number of people that like each category or in each category, whatever we might be talking about. The question says, what percent of the people prefer soccer? So here's how many people like soccer, 9. We want the percent. So we need to know how many people are in this graph. So this bar is 9. We have 4, 13, plus 6 is 19, and then plus 3 is 22. So there's 22 total. 9 of the 22 like soccer, which is about 41%. Pictographs, which are actually something that we said is a bad graph. Pictographs use pictures as a replacement for bars, which is silly because we could just use a bar graph. What makes this misleading is the pictures are different sizes. And what makes that misleading is it looks like more people like banana than apple or cherry, but there's 4 bananas, there's 4 apples, and there's 4 cherries. So these should all be equal. Bananas look like a way more popular fruit than cherry. Okay. This doesn't talk about the graph on the left, but what are other things that can make graphs misleading? You should always have your y-axis start at 0. You should not have your scale skip numbers, and there's a couple other things that we had talked about. Things to look out for when you see graphs in the media. They can be misleading. This one's called a dot plot. So we have, keep going. We have numerical data here, and we just put a dot for each time there's a 0, each time there's a 1, whatever this data is. So this isn't a perfect graph because there's no label and no title, so I don't know what I'm looking at here. But it's kind of a number line-esque graph here. We call it a dot plot. If I ask you to describe a graph, what I mean is to talk about socks: shape, outliers, center, and spread. So with shape, you have options of symmetrical, skewed right, and skewed left. This one doesn't really have a tail to either side. It's not a perfect example of symmetrical, but we're going to go with that for this one. It doesn't appear, and we could do the formula that I just showed for 5-number summaries on this. It doesn't appear that there's any numbers way smaller or way larger than the rest of the group. So yeah, 12 is a bigger number than 0, but there's a bunch here by 10. So 12 wouldn't come out as an outlier in the formula, and neither would 0. The center is the median. So finding the median, we would count up all the dots, which I've done for us, and we would cut it in half. So this spot right here is where that halfway point would be. So the center is 5, and spread is just the minimum to the maximum. So 0 was the smallest and 12 was the biggest. If it says to describe the graph, or if you see the phrase overall pattern in a question, that's talking about SOCS, socks. Okay. Here is a stem plot. All right, maybe you've heard of it as a stem and leaf plot. There's a lot missing from this graph: a title, a label, or really a key. I would need a key to know this. So this piece of data, is this 0.4 or is it 4? Is this 33 or 3.3 or 330? I don't know what these numbers represent, so it makes it really hard to do the next part, which is analyze everything. But if I was going to try, if you wanted to try to smooth this over, it looks like we would have a tail to the right, which would mean that this is a skewed right graph. And I'm not going to be exact here because I don't know for sure what the numbers are. If this was 127 and this was 4, then there'd be some outliers in here. So I'm just going to go off what it looks like this time, even though we have a formula. I would say 116, 127, and 4 would be our outliers. The center would be where the halfway point is. So there's 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15, 16 pieces of data. 16 divided by 2 is 8. So in between the 8th and 9th piece of data would be our center. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here's where we would have our center right in between these. So if this was 41 and this was 43, halfway between those would be 42. Spread is 4 to 127. Very spread out data. All right, here's a histogram. The main difference between histograms and bar graphs, because they both use bars, is one is for numerical data, so how many feet tall something is, okay? Where bar graphs are for categories, like favorite color or favorite candy or whatever. So histograms are for numerical data, bar graphs are for categorical data. One quick way to tell which one's which is if there's gaps or not in between the bars. Histograms, the bars go right next to each other with no gaps. Bar graphs have to have gaps in between the bars. Describing the graph, that's socks. It would look like a symmetrical graph to me. There are no apparent outliers, no bars that are way over here or way over here. The center, so we should talk about that. Center of a histogram, we would need to know how many pieces of data there are, which I've done for us. If you add up all the bars, how tall they are, you get 31. Take 31 and cut it in half, and you get 16.5, which means the 17th piece of data is where the center is, where the median is. So we're going to count these bars up until we get to 17. We have 3 plus 3, which is 6, plus 8 is 14. 14 plus 10 is 24. So here we only had 14 pieces, now we have 24. So the 17th piece is somewhere in here between 75 and 80. Spread is smallest of 60 feet, highest of 90 feet. These are called box plots, which go with the minimum, Q1, median, Q3, the 5-number summary that we had talked about on the previous slides. For these, identifying these, the minimum is here, quartile 1, median, quartile 3, and maximum. I don't know how these arrows got so far off. Just get rid of them. All right, the stars represent outliers, so they kind of get thrown out of the data. One thing about box plot is even if it doesn't look like it's equally spaced out, between minimum and Q1, that's 25%. And same with this piece, and with this piece, and with this piece. Each piece is 25% of the data. Okay, even if it looks like it's more spread out. So we'll keep that in mind for a question coming up. So this is called a box plot. Yes, there are outliers. The way we can tell is that they are stars. They're disconnected from the rest of the graph. What percent of males scored less than 61? Okay, well, here's 61. This is an outlier, so it's getting tossed out. So 61 is actually our maximum. So everything less than 61, each chunk is 25%. So 25, 50, 75, 100%, everybody scored less than 61. Less than or equal to 61. All right, if it would have said between 29 and 42, well, that would be 25 plus 25, 50% of the people, of the males live here. Okay. Comparing the two graphs, we don't use socks for that. You could talk about females having a smaller minimum. You could talk about males having a larger IQR, all those vocab words that we've talked about before. A lot of good answers for that. And that's about it for this one. So on Schoology, start your quiz number 2.